1526. We'll take a look at 1525, which is similar, and there's a lot going on here, but you know, put things in order and we'll try to simplify it a little bit, hopefully. So we're talking here about the IRS and you know, who does what kind of tax returns and whatnot. And in any event, take your data and enter it, you know, like I did, and my sample size is 50, which is just the sum of these, right? Okay, kind of ignore some of this stuff, some of this noise for a little bit until we get into it. Okay, then if you go and you look at the formula on page 555, okay, what we have to do here is calculate. We're really gonna use the upper limits here, sorta, but 20, we got to start with that as being an upper limit, and what we're gonna try to see when we look at these is, you know, what in a normal curve, you know, what percentage would fall, say, below that number that we arrive at. And I think I can show you that as we go along here a little bit. So look at our formula, and we got to put in a few things that are given to us. In this case, our mean is 44.8, that's given to us, and our sample standard deviation is 9.37, that's given to us in the problem, and I believe those things are given to you in your problem as well. Yeah, okay. And so again, we're going to go to 20 first, because even though, you know, there's one there's one that happened between 20 and 30 in a normal distribution, there is a probability that it would happen, that there's some that would be less than 20, right? Okay, there is that probability that there might be an accountant that has less than 20 clients. So we use and I just put the 20, 30, 40, which is the upper, you know, 20, 30, 40, 50, 60, 70, okay, the upper bounds for each of these. And I want to do that formula, which is just that it's my x minus my mean of x divided by my standard deviation. So equal to x minus my mean of x, okay, and use my F4 there, okay, and I need some parentheses there. Sorry, I need to put parentheses around that part of the equation thus far, okay, and then divide that by my standard deviation, and that gives me this 2.64 674, 2.65, let's call it. So what's that mean? Again, if we pull up this thing and minus 2.65, minus 2.65, so we come here and we follow along, and I got my z of minus 2.65 right somewhere's around here, right there. Oh, I missed it. Doggone it. I found another one that's a little easier than to do some of this on, but we'll try, see if I can get her. I can't get her. There we go. So 0.4%, or 0.4%, remember we express as 0.004. So that's the area, right? So it's there's a 4/10 of 1% chance, you know, that somebody has up to 20 clients. Okay, then we do the 30, and since we used our dollar signs here, and I didn't for this one, I need to oops, I'm sorry, let's escape there and go back to here, and I can put dollar signs there, hit enter, shouldn't change that one, but then as long as I did that, I can copy and paste this down here, right? Changed my color, doggone it, but I'll change it back. There we go. So now I want to know this, and ignore some of this, because I did this the old-fashioned way. Now that I've got this other handy tool, it's kind of nice. So I've got a 30, and then up to 30 is a minus 1.58, let's call it, right? So I come here, and I'm just looking for a z that's 1.58. Boom. So I got 5.71, or 0.0571, right? 0.0571, okay? And that's up to my 30, okay? And that's up to my 30, so it kind of includes this area, and then the area that would be in between there, I guess you would say. So now I'm going to input that up here, okay? So I've got that is equal to my number that I found here, okay? we're going to kind of ignore this 20 because it's not a part of this when we actually get up here, and we got a little other stuff that we got to do too. Okay, then if you do that for each of these, and you just look up that minus, or minus 0.51, okay, and that's not rounded, so minus 0.51, we got to come over here in our Z, and it's going to be up here someplace, right? 30.5. Okay, I got to change some stuff here. Okay, and what I'm going to do, sheet D2, I wonder where I got that from. Huh. I'm going to just take this and mark this as my point 30, is it 30.5 through 50. Okay. Now I'm going to say that this is equal to this minus this. Okay. And why do I do that? Well, what I'm trying to find then is that the area that is between this 30 and 40, right? Okay. And if I look back at this, okay, you know, I was 0.51 minus 0.51, and what was my other one? One, you know, somewhere around down here, right? Right there. Okay, and so I'm really looking for this area that's in here, and this chart doesn't let me really demonstrate that, but I'm looking for that area there. Okay. And I find that just by subtracting then this 30.5 by subtracting the minus the 5.71%, sorry. Okay, then I go on, and now I'm flopping over to a positive number here, but my 50, and I get 0.55. Okay, and so I can, 0.55 is what I got to find. And that's positive here now. Okay. 70.88. Okay, so I'm going to enter that in here, right? 0.7088. And again, I've changed kind of the way that I've done some things, and now I can say that this is equal to this one minus this one, right? Okay, because that area is going to be in between there, so it's going to be about 40, right? Yeah, about 40%. Okay, and I do that again for this one, 1.62. So we'll click there, and we come to here, 1.62. So I got 94.74. Oopsie. 0.9474. Okay, and again I have to then is equal to subtract this from the 9474, and that area is going to take up about 23%. And then lastly, I'm here at 70, and it's 2.69. So let's get to there. It's going to be way the heck out here, isn't it? Yes. 99.64. So I got 0.9964, and this is equal to this minus this. Okay, and I would have a remainder here then that would be over 70, much like my under 20. I would have a remainder here that would be a 0.0036. Okay, that should get me to the 1, and I may need that actually in here. I'm going to pause for a second. I think what we can do for efficiency's sake, instead of saying this, because this is at our upper limit, remember we've combined these two up here. Okay, we can do the same here, and instead of making this 0.99, just make this a 1, right? And then that gives us a number, and this would include the stuff that's over 70, much like this is going to include the stuff that's under 20 when I come to here. Okay, so then I just pick up these numbers, right? So I said that this is equal to this one, you know, and you can see my numbers all correspond down here. Okay, then what do? Well, then I take that number and I multiply it times my mean. Or not my mean, I'm sorry, my sample size. Gosh. Right? So it's equal to this times my sample size. Because we're going to do, that's giving us proportions, basically. Oops, and if I do my sample size as 4, then I can just carry this down. Okay, and that should still add up to 50, right? Should still add up to 50. And it does, okay? Then I take my B2, what I actually had as a frequency. This is an expected frequency, is what we would call this line here, probably my F sub E. So I subtract my actual frequency, or I subtract my expected frequency from my actual frequency. So I say this is equal to this one minus my actual frequency. I'm sorry, I did that backwards. I subtract my expected frequency from my actual. I think I said it right and just did it wrong. Okay, there we go, and I can carry that one down. Bingo. Okay, and then I square those values. So that's just equal to this squared. And this formula is kind of the same one we did on the frequency one. It just gets a little more complicated when we do it like this. Carry those down, and then I divide my this by, I divide this by my expected frequency here. Okay. And I can carry that down. Okay, I sum that, and actually I'm not even going to use this number in the future, but it's alright. Oops. I don't think I'm going to use it. And the reason I'm not is because if you go back and you look on page, I think it's on page 355, somewhere's in there, it might be 354, but it says that, if we have frequencies that are less than 5, we might end up wanting to combine those, okay? You still got to do this math, because if you combine them first and then you try to do the math, the x minus the mean of x divided by the it doesn't work. Okay, so you got to do this all the way up here first, and then you can combine things. Okay, and we can combine things a little bit, and then we still got to do a little bit of math to come up with something. First though, let's do the combination. So I'm going to combine these ones because this one's less than 5, and I'm going to combine these ones, right, because this one's less than 5. So I'm going to have 20 to 40. I should have that labeled maybe in here, but my 20 to 40 is going to be 16, right? Simply equal to, this plus this. Okay. That's going to be the same thing. These are my two areas, so I can simply add those, and since I added that, I can just combine it. Okay, and I got the same thing going on here. I can combine my D's to get me an answer there, and one more. Okay. Now from there, then at this point I got to redo my thinking. I got to redo my math a little bit because I've combined these, and now I've got to square these, and you can tell the math's going to end up being different here. So I've got to take this as equal to this squared, okay. And then I go back and say that it's equal to my F9 divided by my D9, so it's equal to 9 D9. Okay. And then I can carry these all the way down, right? And same thing, this is equal to B5 plus, it's equal to this one. I don't think you guys have to do as many combinations here, so yours is going to be more like this up here probably. And just carry that down. Oops, I did something wrong. Oh, because I forgot to do my new math there, didn't I? Yeah, so I only want to carry this to here, right? Yeah, or can I carry it? I think I can carry it one more, and then I got to square this, so I can just kind of do that. And then I've got to do that. Yeah, I think I'm still wrong here. Shoot, 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 shoot. Let me fix that. So that's equal to b. This one I can do. This one's fine. And then this one is that plus that. That should be right. But that's, I've got that. Nope, because I got to square this. So this is equal to this squared, sorry. And then I can take and drag this down here, I think. Yeah, no, I can't. So this is equal to, I got to copy this one. Gosh, sorry. There we go. This is actually my value. Okay, this is actually my calculated value, but I got to go find my critical value, right? Okay, and this is that chi-square test. Okay, and we do this based on our combined here. Okay, so I've got 1, 2, 3 categories. I don't use the 1, 2, 3, 4, 5 categories. I use the combined categories that I had here. And I don't know, again, if you guys are going to have some combined ones or not. It doesn't look like it. Okay, so your guys' will be a different answer. So I look at this, though, and I got 1, 2, 3, but my degree of freedom then, right, is 2. Okay, and so I go to my chi-squared, and my significance according to the problem was 0.05. So, and 2 degrees of freedom, so 5.991 is my critical value. And this one is stated weird. Okay, this one's kind of stated weird, and so I've got to be careful with my hypothesis here. And let me show you what I mean, because it says that, is it reasonable to conclude that the sampled data are from a population that follows a normal probability distribution? So what I would say there is that that is my alternate hypothesis, right? That it is it reasonable to conclude that the sample data are from a population that follows a normal probability? So my null hypothesis is that it's not a normal distribution, right? Okay, that it's not a normal distribution. Okay, hang on a second. Let me make sure I got that right. No, I said that backwards. My null hypothesis is that it follows a normal distribution. Again, it's stated a little differently in this one. Usually I would call that my alternate hypothesis the way it's stated, but in this case I would state that my null hypothesis is that it follows a normal distribution. And I'm going to reject it if my calculated number is greater than 5.991. I cannot reject it. Okay, so I would say that it could be a normal distribution. You can just kind of ignore this chart that I have here. I'm not sure why I have it here. Okay, because this is my calculated value. I compare it to the 5.991. I cannot reject, so it could be a normal population or a normal distribution.